All right, so here we are with the Tuesday assignment for week 9, 8th grade, Advanced Algebra 1. Now this first problem, let's zoom in here. This first problem is a spiral problem, meaning it's something we've already done before. Adding and subtracting polynomials of degree 1 and 2. That's something we've done before, but it's sequenced in the unit structure of our academic year to occur now. So we're actually ahead of the curve here, no pun intended. But let me walk through the procedure again. There are many ways to handle this situation, but I prefer to use what's called the stacking method. What is that? Well, the stacking method takes the longer term, in this case it's a trinomial, okay, 3 terms. Tri means 3, nomial means terms, okay? And this is a binomial, okay? And what we're going to do is stack add and use columns to kind of separate our work. So we'll write negative 9x squared. A lot of people think the use of the ruler for this kind of stuff is ridiculous. But in this instance, we're going to make kind of a grid. So having the ruler to make this kind of table structure is actually quite useful. And now, instead of writing minus 8x, I'm going to put a plus symbol and then isolate that negative 8x over here by itself. Now, I could separate it with parentheses, but this plus symbol is going to become my dividing line, and it'll make more sense in a minute. And now plus 6. Notice how much space I'm putting between the terms, okay? I'm kind of spreading it out. Now, beneath it, we want to line up the linear term. So let's go over some terminology. A term that has degree 2, okay, or raised to the power of 2, is called a quadratic term. All right, if I were to graph this term, it would look like a hoop, okay? A linear term like 8x or 9x or whatever, it's a linear line, so that would graph with like a line, a straight line. So that's what we mean when I say linear and quadratic terms. We're about to get into quadratics in a big way, so getting that terminology fixed and understanding what's meant when I say quadratic term, I mean the term with the square, okay? This is a linear term, and then this number right here is called a constant, okay? Constant meaning it doesn't change because it's just a number. All right, so I'm going to place the linear term 9x, positive 9x, underneath the linear term negative 8x. So we'll put in here plus 9x, lining up everything, okay? And plus 9, okay? So plus 9. Okay, well, this is a fairly straightforward process. If you wanted to if I wanted to clarify something for you, this is 0x squared. So now you've got a trinomial and a trinomial. The 0 times anything is 0, so that's why it's just not there at all. Okay. But including that missing term will become useful if, for example, we were asked to add this to 9x squared plus 9. And then we would have a missing linear term, and putting that plus 0x would actually help us quite a bit. Anyway, it's not so important here. Let's draw a line like we're going to add, okay? and then put a huge plus symbol here. And now we're going to use our dividers. So I recommend dividing along those plus symbols so that you're working with columns, okay? It makes life a lot easier, and it lessens the likelihood of a mistake. So, I mean, when I see people trying to do this horizontally, they'll typically be drawing like lines from the 9x to the negative 8x, and it's very confusing. This is ridiculously simple, and I'm using this about myself here, not referring to the student. It makes it idiot-proof, and I'm an idiot, so I want to make things idiot-proof. Okay, so negative 9x squared plus 0x squared is negative 9x squared. And now let's see if I'm going to have a plus or a minus here. I've got negative 8x plus 9x. Well, that's going to give me positive 1x. And I'll, just for the purposes of demonstrating something here, I'm going to put plus 1x. Now, you know that typically whenever we have a 1 as our coefficient for a variable, we just omit to write it. But it's actually very useful to write it, and I wish mathematics would change and start writing that, okay, along with the exponent 1 here, so that you would understand, okay, degree 2, degree 1, right? All right, so let's see now, plus 6 plus 9 is 15. We have plus 15. Yeah, when they leave those ones out, a lot of times students are left kind of confused. Okay, so let's just finalize this by making it look pretty. And we'll write negative 9x squared. We'll kind of tighten everything up. Plus x plus 15. Okay, and we can feel pretty confident that that's right and put that in a red box. Now, I probably should have chosen a subtraction problem. It's the subtraction problem that gets people, because you end up having to distribute the subtraction sign as a negative 1 to each of the terms to the right of wherever that subtraction sign is, but we didn't get that this time. Let's see what's going on down here with number 2. So it's actually the same skill written a different way. Okay, so find the sum. So add negative 7x squared minus 1 and x squared minus x minus 5. We have just encountered the very thing I was talking about when I was discussing why do we put in a 0 x squared somewhere. This time around, we have the situation I was describing. We have the quadratic term. We are missing the linear term, the one that's just x by itself, raised to the power of 1, that you never see. Okay, and then minus 1. So if we're not careful here, we'll make a big mistake. So let's get after it. And we're going to start by stack adding. We'll start with this trinomial on top. Okay. So I'm going to put a 1 in front of the x squared. You'll see why that's important in a minute. When I combine that 1x squared with the negative 7x squared, having the 1 there will make it a lot easier to understand what to do mathematically. Okay, so 1x squared. And then again, here we're given no help. We're going to insert a 1 right there, okay? And we're also going to put that plus. Remember, there's no such thing as subtraction in mathematics. There's only the addition of negative numbers. So keeping that in mind, we'll put plus and then negative 1x. And then again, we have minus 5, so plus, and then off here by itself, so it's really super clear, negative 5. Okay, so now look down here, what do we got? The next term, negative 7x squared. So that's going to go underneath this 1x squared. We'll put negative, and now that because I wrote the 1, I know exactly where to put the 7 right beneath the 1. X squared, line everything up. And now we have the situation where we're missing the linear term. See, it just jumps to the negative 1. Okay, so look, we have plus negative 1. But what's going on here? Okay, well, here's what's going on. Plus 0 x. Hugely beneficial, okay, to plug that hole with a 0x. In fact, when we get into quadratics, it becomes essential that you do that sometimes because we're looking for terms that add to be 0 and multiply to be some other number. Okay, so now let's add, okay? So we're going to add. It said find the sum, so we'll do that. And we'll break out our column method. Okay, let's work on this one. So what's 1 minus 7, right? That's going to be negative 6x squared. And then what have we got here? Negative 1x plus 0x is going to be minus 1x. So I'll go ahead and write negative 1x. Notice that I just keep interchangeably using minus and negative. And now we have negative 5 plus negative 1. Okay, so you're adding two negatives. You're going to end up with a larger negative or a greater magnitude negative number, which will be negative 6. Okay. All right, so now when we combine these together and make it pretty, I'm going to drop that 1, and I'm just going to write negative 6x squared minus x minus 6. Okay. I think the number one mistake that most students make is that they rush. See, we're taking our time here, and I mean, is it possible that I am making a mistake right now? Absolutely. You know, I mean, I have no answer key, so I'm just doing the math. But I'm trying in all instances to eliminate the potential for a silly error. All right, moving on. Now we are literally jumping from where you were in your life to a very special moment, okay? Because we are now about to enter the land of quadratics. And this is called binomial multiplication. Binomial, meaning there's two terms here, and we're multiplying by two terms. Binomial multiplication. And what the process is called, binomial multiplication, is called binomial expansion if it was just x minus 2 squared. Okay, but because it's x minus 2 times something else, some other binomial, we'll just call it binomial multiplication. There's two ways to do it, and you're going to learn both. There's the box method, and then there's what's called the FOIL method, where we multiply the first term by the first term, FOIL, F-O-I-L, first, outer, inner, last. First times first, So 5x times x, outer times outer, negative x, sorry, pardon me, negative 1 times x, inner times inner, negative 2 times 5x, and last times last, negative 2 times negative 1. For starting out, I think it's better to use the box method because you're filling in a box and you don't have to worry so much about what does F, O, I, and L stand for. Okay, so what do we put up here? It doesn't matter. Okay, it doesn't matter. But I tend to put the larger number up there. That's just a personal preference thing, so I'll put the 5x here. And then what you do is you see, you put the negative 1 in its own box, like it's a negative 1 and not like you're putting a minus 1. All right? And then you do the same thing here. You put the x by itself, and then you break that negative 2 off, and you stick it down here, negative 2. And now you kind of fill out the table. So it's x times 5x. Well, there's a rule called the product rule, which states that, and this is something that we're going to have to learn, but we're going to go over it every time until you guys get it. So the product rule for exponents states that if the bases are the same, you add the exponents. So in this case, we have 5x, again, I wish they would just to the first power, okay, times x to the first power. And what the product rule says is you add those exponents. Okay, so what does that equal? Well, we're going to have to put what it equals down here. We don't have space. It would help if they would put the 1 there in front of the x to the first. So what you do is you multiply 5 times 1. Okay, it's just 5. So nothing weird there. And now x times x, you have x raised to the power of 1 plus 1. Okay, well, what's 1 plus 1? 2, right? So now you've created a quadratic term, 5x squared. Okay, and that's how that 5x squared comes to be. So in here, we'll put 5x squared. And that's going to be the only quadratic term, okay? Because nowhere else are we going to multiply two x's together. And now you can fill the rest of this table out in any order you want, but the next term is the linear term, so we might as well fill that out. 5x times negative 2 gives me negative 10x. And then the next linear term is here. We have 1x times negative 1 gives me negative 1x. And I'm going to write that out as negative 1x. It's actually going to be really useful here in a second to put the 1, the negative 1, okay? Now finally, negative 2 times negative 1, a negative times a negative is a positive, so we end up with, and I recommend writing plus 2. And now it's time to sort of assemble our standard form quadratic equation. Now, notice that these two terms here, and this always happens, these diagonal terms here are like terms. So they're both linear terms. They both have those exponents of 1, right? So you can add them together. So when we write out our final product, we'll write 5x squared. So we always lead with the highest exponent term. And now we got to figure out what this is going to be. negative 10x minus 1. So that's negative 10x plus negative 1x is negative 11x. So minus 11x. Okay, and what's left? Plus 2. Okay, so plus 2 is left. And that is the product of those two binomials. Okay, so we can just put them in a red box. And you've just written a standard form quadratic expression. It's not an equation because there's no equal sign. But the standard form is, and this is something you're going to have to get drilled into your head, ax squared plus bx, of course b can be plus or minus, plus c. Okay, so, and you know what I would like to ask is, you know, what's a, b, and c? A equals, b equals, and c equals. Get into the habit of doing this on every problem, then you're going to save yourself a lot of time later. So a corresponds to 5. See, it's the number in front of the x squared. So we just write a equals 5. What's b? This is one you got to be real careful. B is negative 11. Okay, so it takes the sign that's next to it. So it's negative 11. And what's c? C is 2. Okay. There's a lot of cool things we can do if we know what a, b, and c are. All right, but that's not necessarily the point of that problem. Let's move on now to number 4. Use the box method to distribute and simplify. Okay, so this time they didn't give us the little box. They just want us to draw it, and that's good. So you got to think, how many terms by how many terms? I got a binomial by a binomial. So I need exactly what was in that previous problem. I need a window like this. Okay, and then I have 2 rows. And 2 columns. Just like that. Okay. Now, up here above, I'm going to write negative 3x squared. Okay. And then over here, I'm going to write 3x. You could put the plus symbol. It doesn't matter. And then here, I'm going to put 3x. And here, I'm going to put plus 1. All right, so now it's time to multiply. So in this box, this is the hardest box. First, we multiply the numbers. 3 times negative 3 is negative 9. And now you really have to think about that product rule, right? So this is x to the first, and you're multiplying x squared times x to the first. Okay, so over here, what's going on? Well, you add those exponents, you're going to have x to the 2 plus 1, right? And what is 2 plus 1? X to the third power, and we call that x cubed, okay? So it's negative 9x cubed. So this is going to be a cubic equation. This isn't something we're going to get into beyond just doing this kind of stuff. And now we have, here comes our, that was our cubic term, here comes our quadratic term. 3x to the first times 3x to the first. Now, you know, you could just say, hey, that's the same thing times itself, so that's just 3x squared, right? And you're right, because it's 3x to the first times 3x to the first. And what I mean by 3x squared is something quite different from the way it may have sounded. What I mean is, there are these parentheses, okay, and then inside is the 3x. Now you might think, okay, what's the difference between that and just writing 3x squared? Okay, well that's completely wrong. So this is another rule of exponents called the power rule. And what happens is you actually multiply that 2 to the exponents of each of these terms. Okay, so the 3 has an exponent of 1, and the x has an exponent of 1, and so you end up with 3 squared times x squared. Okay, well, what is that? That's 9x squared, right? Okay, so we're going to put, and it's positive, so we'll put plus 9x squared. And again, you could have done it that without the power rule. You could have used the product rule and just said, okay, 3 times 3 is 9, and then x times x is x to the first times x to the first is x to the 1 plus 1, using the product rule, x squared. Either way, you'd get 9x squared. Okay, moving on, we have negative 3x squared times positive 1. Okay, so that's just going to be negative 3x squared. And now we have 3x times 1, which is just plus 3x. And notice again that this diagonal has like terms. And it always will. It always will. So let's write it out. Again, highest exponent listed first would be the cubic. So we're going to lead with negative 9x cubed, x to the third. And now we got to figure out what's going on with x squared. So I've got 9x squared minus 3x squared. So that's like 6x squared plus 6x squared. All right, now the next thing is the linear term, plus 3x. You might be saying, hey, where's the number that's all by itself? It's there, but guess what it is? It's plus 0. Okay, so there's your cubic in standard form. And we typically omit that plus 0 because it doesn't, I mean, I don't necessarily think we should omit it. It's perfectly valid mathematically, and it makes all the sense in the world to include it, but math developed, you know, math is not merely an objective, like, physical law of the universe. It's something that developed over time, and there's certain conventions that we use that humans invented, and I think they got some of it wrong, but I'm not in charge. right? Written as a simplified polynomial in standard form, what is the result when 3x plus 8 squared, that's what I was talking about before when I was mentioning that when you've got something that you're going to square, instead of calling it binomial multiplication, we call it binomial expansion. So you're expanding the binomial by multiplying it by itself, is subtracted from 9. So we'll get to this. We're going to save this for the end, okay? Because that's confusing language. Is subtracted from 9 doesn't mean minus 9, okay? It means 9 minus all of this, okay? So, but we'll get to that at the end. The hard part is going to be doing this deal. So first, we need to actually figure out just what on earth is being asked of us. So we have 3x plus 8. And it's squared, okay? So now what? What does that mean? Well, if you think about, like, if I said 5 squared, you could write that as 5 times 5. Okay, so if I'm saying blah squared, you could just write it as blah times blah. So blah in this case is 3x plus 8. So I'm going to put 3x plus 8 in a parenthetical expression, and then I'm going to multiply it by itself. Again, just pushing the parentheses right up against it indicates multiplication, 3x plus 8. And this time I'm going to teach you the FOIL method, because it's, I mean, you got to learn it, okay? F-O-I-L, FOIL. And here's how I'm going to teach this. So this is the first term, 3x. So when we say first times first, that's going to be 3x times 3x. Okay, so I'm going to use these colors and arrows to make this super clear. So 3x times 3x, that's my f in FOIL. Okay, we'll get to what it is later. Now, outer times outer. Well, so these are the outer terms, 3x times 8. So here's what we're going to do there. Outer times outer. And that's my O. Inner times inner. Here are the inner two terms, 8 times 3x. Okay, and that's the I of FOIL. And then last times last, 8 times 8. Okay. And that's going to be the L term. So you see, it's really important to understand the structure, right? There's another way to write this. We call it the half moon style. But for now, this will work fine. So the way I recommend doing this for the first few times that you do it is that you do all the intermediate steps and you write them all out so you don't make any little mistakes. So I'm going to put the equal sign way over here and you'll see why. So first times first is 3x times 3x. So what I'm going to do is in a huge parentheses, I'm going to put 3x times 3x. Okay, that's my f for first. Then I'm going to put a plus sign. And then I'm going to do an open parentheses. Here comes the outer, 3x times 8. 3x times 8. You know, if you do it this way and you make a mistake and you bring it to your teacher will be able to spot the error very easily. Plus inner times inner, 8 times 3x. Did you notice something here? These are the same. And then last, 8 times 8, so plus, open parentheses, 8 times 8. Right? So that's that intermediate step that I hardly ever see anybody write down. And it would save them a mountain of trouble if they would do it. So in the first parentheses, we're going to have to apply that product rule. You have 3x times 3x, so that's 9x to the 1 plus 1, 9x squared. So we're going to drop the parentheses and write 9x squared. And now I have 3x times 8, that's plus 24x. And then here I have 8 times 3x, which is plus 24x. And then we have 8 times 8, which is 64. There's some interesting patterns here, okay? So we'll talk about those in a moment, but let's go ahead and finish working this out as if we didn't know those patterns. So we have 9x squared plus 48x plus 64. And what we just did was we just expanded the binomial. Now there's some interesting stuff to notice. Notice that this was 24x plus 24x, so that's like 2 times 24x. And then 9x squared was really 3x. Like up here, it was 3x, the whole thing squared, okay? And then notice over here, the 8 times 8 was kind of like 8 squared, right? So if you have a binomial that is in this form, a plus b squared, okay, then the general form of the expansion of that binomial is always the same. It's a squared plus 2ab plus b squared. Now, I'm not asking you to memorize that, okay? If you need to use FOIL or box to expand squared binomials for the rest of your life, fine. It works just fine. But you'll get the same answer. And if you can remember this, there's another one for the difference. But it's a squared plus 2ab plus b squared. So that's a good way to check and see if you got it right. So this is the answer. But this is super useful. And now we have to bring in, I'm going to call this part 1. Okay. So like we got that first part. Now is subtracted from 9. Okay? So let's write that down. Okay? So let's write 9 minus, and then you need to put this whole thing in parentheses and put 9x squared plus 48x plus 64. Now, do you see where the mistake is going to come in? Big mistake if you don't think, okay, this is a -1, and I'm going to multiply that -1 to each of these terms. And all you're doing is changing the sign, okay? So you end up with 9 plus, remember there's no such thing as subtraction, 9 plus, and then you have -9, because you've distributed the -1, -9x squared. Flip the sign as a minus 48x now. And then minus 64. Okay. And now I recommend that what we do is we stack add, right? So it's 9 plus, it's adding 9. So we could just write this like this, -9x squared minus 48x minus 64. And then I'm going to put here 9 underneath the -64, and then add the whole thing. Okay? And again, you can separate this out. And this is 0x squared plus 0x. And then this is plus 9, right? That's a positive 9. So really the only thing changing here is -64 plus 9. So that's really 64 minus 9, and with a negative sign at the end. So that gives me negative, and then 14 minus 9 is 5, -55. Okay, now the rest of the stuff just comes down because it wasn't changed. So we have -9x squared minus 48x minus 55. Let's put it all together. So our final answer is -9x squared minus 48x minus 55. Okay, and that's going to be, the problem was really tricky in the way it was worded. I think the vast majority of incorrect answers would just be people doing the first part and then subtracting 9 from positive 64, and then not understanding about this whole distribution of the negative okay? Because it was this thing subtracted from 9, not 9 subtracted from this thing. Okay. So we are now done with number 5. And let's look at number 6. Written as a simplified polynomial in standard form, what is the result when blah, blah, blah is subtracted from? So that means we write this down, and then we expand this binomial, and we take this, put it on top, and subtract this from that, okay? So this is subtracted from that, not the other way around. Okay, so the first thing we need to do is expand that binomial. So we may even want to write it as a step 1. Expand binomial. Okay, so this time I'll use the half moon method of FOIL, okay, as opposed to that kind of grid structure that I drew. So now we're going to write 2x minus 1 multiplied by 2x minus 1. All right, now let's see what happens, because this one isn't the plus, this one's the minus. But here's the half moon method, okay? You'll see what I mean. So it's first times first, right? So the student actually showed me this. First times first, outer times outer. So this is, look, it's starting to form like a crescent moon. Inner times inner. And last times last. Okay, and you know, that's, you see, that's kind of the, we're drawing some stars here, right? I don't know why there are stars on the moon, but anyway, it's a stellar object anyway. So that's the half moon method. And some students find that to be really memorable. They can remember, okay, first times first, 2x times 2x, outer times outer, 2x times negative 1, inner times inner, negative 1 times 2x, last times last, negative 1 times negative 1. And whatever, you know, cranks your chain, okay? Either way, you're going to do first, outer, inner, last. So the result is going to be the same whether you do it this way or the box or the other way I showed FOIL. Again, I want to see this intermediate step, 2x times 2x. Plus outer times outer, 2x times negative 1. Plus inner times inner, negative 1 times 2x. Last times last, negative 1 times negative 1. Okay, kind of got crammed in there, but now we're going to put it together and drop all the parentheses. So 2x squared is 2 times 2 times x, okay? So that's 4x squared. Remember what I'm saying here. I'm saying 2x squared, okay? Not 2x squared. They sound exactly the same when you say it out loud, but it's totally different in it. Because this 2 goes here, and on that one, nothing happens. Okay, so anyway, but moving on. 2x times -1, it's going to be negative 2x. -1 times 2x, so it's going to be negative 2x. And then -1 times -1 is positive 1. Okay. So notice again, we have these middle terms that are going to combine. So we have 4x squared minus 4x plus 1. So what can you take away from this structure? A minus b squared. Because that's kind of the structure we had. And the structure is that that's going to give you a squared minus 2ab plus b squared. Okay, so just a little different than if it was a plus b squared, it was a squared plus 2ab plus b squared. And here it's a squared minus 2ab plus b squared, because the negative numbers when multiplied together will always be, when you're squaring a negative, it's going to be a positive. So anyway, there's just slight differences. I'll put the other one beneath it so you can see the difference. So this is a plus b squared. Okay, the only difference is this symbol right here. This is going to be a squared plus 2ab plus b squared. And this only works when you're expanding a binomial, okay? Not when you're multiplying two different binomials together. It doesn't work like that at all. There's a really cool feature that comes about when you have this binomial multiplied by this binomial. But we'll get to that later. So that was kind of part one, wasn't it? We had to create this binomial. Pardon me, we had to create this quadratic, this trinomial, okay, this standard form. Now it said, is subtracted from. So I would like to propose that we not do subtraction, but that we do addition. And so here's how we do addition on this. We're going to multiply that whole thing right there by -1. And that way we can add it. We'll be able to add it to 5x squared minus 3x minus 5 and not have to worry about we're going to do the distribution of that negative symbol first. And this is how you turn a subtraction problem into an addition problem. Okay, so again, this is a way of making life easier for you and less prone to error. Isolating the steps, okay? So we're going to distribute and multiply the -1 to each of these terms. And all that's going to do is change the sign of each of these terms. So that's going to give me -4x squared plus 4x, and then -1 times +1 is -1. Okay, so now we can add this. We can put this on top and stack add this, okay? Because we've already distributed the negative. We turned it from a subtraction problem to an addition problem. So I'm going to bring that down. You can't see it, but I'm going to write down 5x squared. We can actually just write it beneath it. 5x squared minus 3x minus 5. And notice that I dropped the extra plus symbols because I think you kind of got the idea. But if you want to add them back, you can. So now we're doing an addition problem. And we'll make our little columns so that we can do this in pieces. All right, so now dealing with column 1, I've got -4 plus 5. That's going to give me 1, positive 1x squared. So I'll have 1x squared. Then I've got 4x minus 3x. That's going to give me plus 1x. And now I've got -1 plus -5. That's going to give me -6. So let's write that out prettier, dropping these ones, and just write out x squared plus x minus 6. Okay, and that's your final answer. Okay. Number 7, express as a trinomial. Okay, this is just another way of saying use box or FOIL okay, to multiply the binomials. All right, that's all it's saying, expresses a trinomial. It just wants us to multiply these binomials, okay? So because they're written like this, we'll use the FOIL method, okay? First, outer, inner, last. So first times first. Let's see if we can do it without writing that intermediate step. 3 times 2 is 6, and x times x is x squared. 6x squared. Okay, that's first. Now outer. So I'll put the F here for first. Now outer. 3x times -5. Is going to be outer. So let's see if we can do it. 3 times -5 is -15x. So you got 3x times -5 is -15x, so minus 15x. Inner times inner. Okay. We got 1 times 2x. And that's going to be my inner times inner. Well, okay, that's just going to be plus 2x, right? Notice right away that these terms are like terms. They always will be. And then last times last. 1 times -5 is just -5. All right, so we just have this one step of combining these like terms in the middle, and this is going to combine to be, you tell me. Okay, so we have 6x squared, and then -15 minus -15x plus 2x is -13x. And then we bring down the -5. And that's it. So we cut out a lot of the rigmarole of the work, but you know, all those extra steps are designed to prevent you from making tiny little errors. So if you're not totally comfortable with that yet, go back to the earlier problems and do it a longer way. Okay. Now on to number 8. We're asked to do precisely the same thing. And here I'm going to use the box method just to remind you of how that works. So we create a box that's going to have 2 columns and 2 rows, kind of like a little window. Okay. And then we'll put 3x here and plus 8 here. And then we'll put x right here and plus 6 here. All right. So again, I'm just trying to show you that there's all these different ways to do the same thing. So 3x times x is 3x squared. X times 8 is 8x, or plus 8x. A good habit to put the plus symbol or the minus symbol as it may be. 6 times 3x is plus 18x. And then 6 times 8 is plus 48. Just like in the FOIL problems, we have these middle terms, the linear terms there in the middle, that combine. Okay? They're like terms. So 8 plus 8 is 16. So 18 plus 8 should be 26, right? So when we get to that, we'll write 26x, since they're both plus. All right, so let's write this thing down. Starting with the largest exponent term, I have 3x squared. Plus 26x. Plus 48. And there it is. That's a trinomial. Tri meaning 3 terms, okay? So we took 2 binomials, multiplied them together, and got 1 trinomial. Done. Number 9. Simplify the expression to a polynomial in standard form. All right, all it's asking you to do is, let's rewrite this in normal language. Here's the translation. Very equivalent to just multiply the binomial by the trinomial. And for these situations, I always recommend box. Always use the box method, okay? There are other ways to do it, but none of them come close to being as error preventing as the box. So now think about the box for a second. We need 3 columns, because we got 3 terms, and 2 rows, okay? So 3 columns and 2 rows. So if I'm looking here at the, how am I going to draw this? It's going to be like this. Okay. Now I need to make my column smaller, right? So I can fit 3 terms. Okay. So now what goes up on top is 3x squared. And then here's negative 9x. And here's negative 4. Okay. And then along the side here, I've got 2x and negative 1. Just trust me, you're going to love this box method way more than any other method that someone might show you of drawing a bunch of lines, okay? There's nothing so simple as FOIL when it comes to multiplying a binomial by a trinomial. Use the box. Use the box. Always use the box. Okay, so we've got 2 times 3 and x times x squared. Okay, so I've got 6x cubed. Now I'm expecting a quadratic. So 2x times negative 9x is going to be negative 18x squared. Now I'm expecting a linear term, 2x times negative 4, negative 8x. Okay, another quadratic term, negative 1 times 3x squared gives us negative 3x squared. Now I'm expecting a linear term, negative 1 times negative 9x gives me positive 9x. And finally, that constant term, negative 1 times negative 4 gives me positive 4. Here's something really cool. Notice that we can combine like terms twice. So we've got these x squared terms that can be combined, and also these x terms that can be combined. This is a pattern that will keep going. You know, if you were to keep increasing the number of columns, you would increase the number of times that you would do this. Okay, so let's start working this out by writing the largest degree term first. So the 6x cubed. Now we got to figure this out. Negative 3x squared plus negative 18x squared. That's going to be negative 21x squared. So minus 21x squared. Then I've got 9x minus 8x. So that's going to be plus x, right? Because it's 1x. So plus x and plus 4. Okay, again, we are not in Algebra 1 going to be working too much with cubics as cubics. We will see them. We might even see to the 4th, 5th, 6th, whatever, but we're not going to be factoring them or solving the cubic or anything like that. We're not even going to be graphing the cubic. Not in Algebra 1. You will in Algebra 2. Okay, you'll have plenty of fun with that. Pre-calculus, it gets even crazier. Okay, so that's number 9. So we're done with the second page. And now we're on to number 10. Simplify the expression to a polynomial in standard form. All right, this is exactly what we saw before. Just draw a box, okay, 3 columns, 2 rows, and multiply out the polynomial, okay? So we're going to multiply a trinomial by a binomial. This time I'm going to make the box bigger, so I'm not cramming the information in there. And you know, it's funny, as my students have gone on in the year, they have begun to notice that this tool that I got them, if they still have it on them, if they've lost it, they're really struggling. And I mean, I'll just give another one. But at the beginning of the year, it wasn't so obvious, like, what's the point of having this ruler? Is this guy just OCD? Well, maybe that's true, but there's still a good point to having the ruler, because now you're having to draw these boxes, and I don't know, how else would you do it straight? So upstairs here, we're going to put x squared, and then negative 4x, and positive 5. Okay. Now along the side, we'll write 3x and positive 4. Okay. And now it's just a game of multiply it out. So we already know this is going to be a cubic here. So 3x cubed. We should expect the quadratic here, negative 12x squared. Linear term coming up, plus 15x. Downstairs, we should expect another quadratic, 4x squared. Okay, now time for linear land, negative 16x. And now time for constant land, 20 plus 20. All right, so we can combine these, and then we can combine these. Okay. So let's start by writing our cubic term, 3x cubed. Okay, so 4x minus 12. All right, so it's really negative 12x plus 4 puts me at negative 8x squared. Now I've got negative 16x plus 15x gives me minus x plus 20. All right, put that in the box. Okay, I only put 2 of these on here for you, just so you could see how it works. But they do occur in the wild, so we have to be prepared. What happens if your coefficient is a fraction? Okay, so I actually want to do this in FOIL, so I'm going to rewrite this like this. 3/2 x minus 1/2 times, and then I'm going to put, well, just write x minus 5/6. Okay, now I'm going to revert back to doing it step by step, the FOIL process, okay? So here's what I mean by that. I'm going to go back to very carefully writing this out. First times first, okay, so that's going to be 3/2 x times x. And that's f, okay? Plus outer times outer. There's the outer, and then there's the other outer. So that's outer. And then in parentheses, what's really going on is 3/2 x times negative 5/6 plus inner times inner. All right, so go inner times inner. That gives me that I. And what does that look like? Negative 1/2. See, this is where people make mistakes. Negative 1/2 times x. And then finally, last times last. Oh, I did not mean to draw that line. Meant to draw it from here. Last times last. So negative 1/2 times negative 5/6. Okay, you can't go wrong if you do it this way. All right? So what does this equal? So that was actually equal. So now what does this thing equal? Let's simplify this down. Well, 3/2x times x is just 3/2x squared. So we can write 3/2 x squared. And now you can multiply across the top and across the bottom to get 15 over, it'll be negative 15 over 12. Or you could get smart and say, aha, I'm going to cancel the 6 and the 3 and make that a 1 and a 2. Make my life a lot easier. So that'll give you negative 5 over 5x, so negative 5x over 4. So minus 5/4 x. All right, moving right along. Now we have negative 1/2x, and I'm going to be smart, okay? I know that I'm going to end up combining terms here, okay? These are linear terms. So why don't I write this as negative 2/4 x. Okay? So put minus 2/4. Then I've saved myself a whole step of finding that common denominator, because I know these terms will always be combining, and with fractions they need to have common denominators. So moving right along, and there's nothing really to cancel here, so this is going to be positive 5/12. Okay. Now we'll simplify in the middle. We have 3/2x². That didn't change. And then here we have negative 5 minus 2. So I have negative 7/4 x. Plus 5/12. And it says, write it in its simplest form. So let's think for a minute about what you might be able to do to get rid of all the fractions. Think about that for a minute. Okay, so delta math is weird. It might want this as the answer, but I'm very tempted to, so I'm going to write this again and show you what I would do. Like, for example, let's just assume this thing was set equal to 0, okay? So that might be the answer. In fact, I'm going to put it in blue. Like, that might be the answer, but there's a way to get rid of all the fractions. It changes the quadratic, though, okay? Because right now, this quadratic is crossing the y-axis at 5/12. So what we're going to do here, we'll change the quadratic. It won't change the solutions of the quadratic, but it'll change the shape of the quadratic. So we are changing something here, okay? So keep that in mind. So this may very well be the answer to put into delta, but this is what I would do. I would not want those fractions, so I would say, okay, I got 3/2 times x² minus 7/4 times x plus 5/12. Now let me just set it equal to 0, okay? Now what I would do is I would multiply the entire equation by 12. 12/1, right? I would distribute that 12/1 to every term. And what happens is super cool. Like here, this 12 cancels with this 2, leaving a 6 to multiply by the 3. Okay, so I'm going to write it out. So this 12 cancels with the 2, so the 2's gone, leaving, and 12 divided by 2 is 6, so it's 6 times 3. This becomes 18x². And I should say, you know, I put that equals 0 because I'm also going to multiply that by 12, okay, which is just going to be 0. So I do the same thing to the left that I do to the right. Again, I don't think delta wants this, but I'm showing you something. So now 12 times negative 7/4 x. So now you're going to divide the 12 by 4, you get 3, right? So you get 3, it's going to be minus 21x. And now the 12s cancel and you have plus 5. Again, equals 0. So that's my answer, okay? It's different because it didn't give us that equals 0 part, okay? It's different than the thing above it. But I want to show you how it's different, okay? It didn't say this, so you can't assume it really, but assuming that was equal to 0, okay, then we could have done it. So what does it really look like? What's the difference? Okay, so take a look at these two graphs. The first one is the graph that we came up with at the end, the red graph, okay? And the one that I wrote is the blue graph. So do you see what I mean? We did change the graph, but we did not change the solutions. See those two places where they cross the x-axis? They're identical, okay? So it is not the same equation, but they have the same solutions. Anyway, I wanted to show you that. I'm fairly certain Delta Math wants the fractional version of what we did, since it didn't tell us that we could set it equal to 0. But I also wanted to show you how you could eliminate those fractions and still get, if you were asked to solve the quadratic, it would be a lot easier to solve the quadratic if you were able to eliminate those fractions. All right, so that's enough of that. Okay, so just back on this, we'll go ahead and put this in the red box so you know what to put into delta. Now that I'm looking at it, I'm thinking there is a way to simplify because everything can be divided by 2. Do I want to do that? I think no, because even if so, I would essentially distribute multiplying a 2 instead of a 12, and I would get rid of this and make this. I would make this negative 7 over 2, and then this would be 5 over 6. But see, that would change the y-intercept. It would actually change the shape of the graph. And I don't know that we should do that. So I'm going to leave it like that. And you guys tell me if that's wrong in delta, and then we can fix it on an individual basis. Okay, moving on. One more problem with fractions. I think we should do it the same way. I think we should write out 1 over 6x plus 5 over 3. And then write 1 over 3x minus 3. Now, when I write this minus 3, I know that eventually I'm going to be, will it matter? No, it won't matter. So I'll just write -3. I was going to write it as 9/3, but I don't think that that's going to be pertinent. Maybe it will be. We'll see. Anyway, first times first. So first times first. Remember, we're going to do this in the long way. 1 over 6x times 1 over 3x. Okay, plus outer times outer, FOIL, first outer, inner, last. Outer times outer. Now you're probably noticing something, but that you could, I could cancel this or whatever. Just do this first. Write 1 over 6x and then times -3. And here I am going to write -3 over 1 because we're multiplying fractions. And then that's outer. So next up is inner times inner. Inner times inner. Okay. We have the I for inner. And then here's our parentheses. That's going to be 5/3 times 1/3 x. And finally, last times last. So that's going to be 5/3 times -3. Okay, 5/3 is last. 5 over 3 times -3 over 1. Okay, so now we can simplify this. This is going to simplify a lot. Not in the first one, though. So in the first one, I have 1 times 1 over 6 times 3. So that's 1/18. And then x times x is x squared. And then I have, this is going to become a negative. But look, I have the 6 and the 3 that can cancel out, leaving behind a 1 and a 2. So this is going to be -1/2 x. Okay, next up we have 5 times 1 over 3 times 3. So that's 5/9 x plus 5/9 x. You notice we're going to have to find a common denominator here between these two. We could do that right now and just say, okay, fine. It's going to be 9/18 over 10/8, and then 10/18 over here. because we got to have the common denominator, right? And then finally, over here I've got 5 times negative 3 over 3 times 1. Well, we can cancel those 3's, leaving behind a 1. So it's just going to be negative 5. Okay, so minus 5. Okay, so this part here in the middle is kind of a mess looking right now. So I'm going to write it out cleanly as a separate step. I'm not going to go ahead and combine it, but just write it so you can read it and see exactly what I did, because my blue pencil wasn't sharpened enough to make it really clear. I've got negative 9/18 x, which reduces down to 1/2. Plus 10/18 x, which reduces down to 5/9. Okay, minus 5. And now it's pretty clear what to do when you want to combine these, okay? So now you have negative 9 plus 10, so it's going to be 1, right? So it's going to end up being 1 over 18x. So now we have 1 over 18x squared plus 1 over 18x minus 5. You know, every bone in my body wants to multiply this equation by 18. But I think that's probably what they want on delta. So I'll write that here. Because remember, if I did multiply by 18, I would fundamentally change the problem. But just do it just watch what would happen if I did. All right. The only thing I would need to figure out is what 18 times 5 is. I think it's 90. Yeah. So what if you multiply this whole thing by 18? If it were set equal to 0, you would eliminate the 18 here, and it would just be x squared. You'd eliminate the 18 here, and it would just be x. And then you would make this into minus 90. Okay, again, those are very different. This has a y-intercept of negative 90, and this has a y-intercept of negative 5. But do they have the same solutions? Let's go see. Okay, so here they are again. Notice the first equation's the one that delta probably wants. That's the green one. All right, see how it's different from the purple one, the one that I made? But notice how they both have the same solutions. They both cross the x-axis at exactly the same point. So I don't know. You know, when you're trying to work with mathematics, you tell me which looks like the simpler equation. But that presumes that you can set it equal to 0, and it didn't tell us we could do that. And it might be relevant, you know, it might be important that it crosses the y-axis at negative 5. Okay, so we can't, you know, we can't just willy-nilly do this. I'm just trying to show you some stuff that makes life easier. But again, it fundamentally changes the shape of the graph. Like, look at the difference. So don't do this. It's like, don't try this at home, right? Unless you know that you can, don't, okay? Because it does change the graph. But, fundamentally, the main point is that what we did to dramatically simplify that problem to be just x squared plus x minus 90 instead of all those fractions, it didn't change the solutions. Those are the solutions, the x-intercepts, okay? Negative 10 and 9 are the answers to the question if you had to solve the quadratic, okay? Okay, so, yeah. Moving on to number 13. Write the following expression as a simplified polynomial in standard form. Okay. Standard form just meaning blank, ax squared plus bx plus c. Okay. Now, here's what you cannot do. You cannot just start distributing that too. You can't do that. The first thing you have to do is work with that exponent. You have to expand the binomial x plus 1. Now, let's see if we can use our little trick that we learned. Remember this one? A plus b squared equals a squared plus 2 times a times b plus b squared. Okay, so here I'm saying that's A and that's B. All right, so let's just write this equals 2 open parentheses. All right, and now let's do it. Let's see if we can do it in our heads, So A squared, x squared plus 2 times a times b. So 2 times x times 1. That's just 2x plus 2x plus b squared. So 1 times 1. 1 squared is 1 plus 1. And that is correct. And, you just saved yourself like a lot of work, didn't you? If you know this, you save yourself a lot of work. And remember, the a minus b squared is the same, except that's a minus sign. Okay? All right, moving on. This one we can distribute the 4. You see, there's no exponent here that we have to worry about. So we can go ahead and distribute the 4 to the x and the 4 to the 1. And thankfully, it's all plus symbols, so no negatives. Hooray. So that gives me plus 4x. We're going to end up with a combined like term situation here in a minute. Plus 4 plus 8 at the end. Plus 8. Okay. So now let's distribute this 2. We're going to distribute the 2 to each term. So we're going to have with this massive jumbled polynomial, and we're going to have to combine all the like terms to get it nice and neat. So we're going to have 2x squared plus 4x plus 2 plus 4x plus 4 plus 8. Okay, now there's only one quadratic term, 2x squared. So we're only worried about the linear terms and the constants. I'm going to circle the linear terms in red. This is where this double-sided pencil becomes really helpful, and I'll circle the constants in blue. Okay. Now we know what we need to combine, and we have to write this in decreasing order of exponents. So we're going to start with the 2x squared. Now, 4x plus 4x, that's plus 8x. And now 2 plus 4 is 6, 6 plus 8 is 14. Let's just make sure. Let's try it backwards. 8 plus 4 is 12 plus, hold on. 8 plus 4 is 12 plus 2 is 14. I said it wrong. 2 plus 4 is 6. And 6 plus 4 is 14. I think I said 16 before, but I meant 14. Yeah, so again, try it maybe. 8 plus 2 is 10, plus 4 is 14. Just 1,000 different ways to make sure you're not making a mistake. And put plus 14. And you're done, right? You have this in ax squared plus bx plus c. What's A, what's B, and what's C? Get in the habit of just knowing it, okay? Just notice it. A is 2, B is 8, and C is 14, okay? That wasn't asked of you in this problem, but it will be in the very near future, that you instantaneously recognize when it's in standard form, you can extract these numbers as A, B, and C. Okay? You need them for the quadratic equation and a lot of other reasons. So we'll put this in a box. Call it good. That was number 13. Done with yet another page. Okay, so here we are. If we remember a minus b squared was equal to a squared minus 2ab plus b squared. Save you 1,000 hours, right? So let's try it. Let's try it together. What's a? So this is a, and this is b. All right. So a squared is x times x, x squared, minus 2ab. So minus 2 times x times negative 3. So that's minus 6x, right? 2 times x times negative 3, minus 6x. And then negative 3 times negative 3 is plus 9. Okay, now we distribute the 5 here. So we have plus 5x minus 15 minus 2. All right, so we're actually ready. We don't have another step to do, so we only have one quadratic term, so we don't need to put a color on it, but we can combine these like terms, our linear terms in red. Negative 6x plus 5x is going to be minus x or minus 1x. And then we've got plus 9 minus 15 minus 2. And we're going to want to take this very carefully, okay? So first, let's just subtract 15 from 9, okay? Well, that would be negative 6. right? And negative 6 minus 2 is negative 8. So what we should end up with is x squared minus x minus 8. We'll check our work again, but just doing it in the head there seems right. X squared, and then I'm not going to write minus 1x, I'm just going to write minus x. And then 9, so negative 15 plus 9 is 15 minus 9 with a negative symbol, right? So it's 6, so it's negative 6. And then you take negative 6, subtract 2. So negative 6 minus 2 is negative 8. So this is minus 8. And that's it. What's A, B, and C here? A equals 1. B equals negative 1. And C equals negative 8. Okay, just keep that in mind. Remember, the standard form that you're fitting here is ax squared plus bx plus c. Just because it says plus doesn't mean it has to be a positive number. All right, that was number 14. And now number 15 is actually something we already did. Okay, so if we remember that a plus b squared is equal to a squared plus 2ab plus b squared. And we can just do this in our head. So x squared plus 2 times x times 1, which is just plus 2x, plus 1 times 1 is 1 squared, so plus 1. That's it. If you know the trick, it was simple. Okay. You can do the same thing here. Okay. Again, I'll write this out just so, because I want you to memorize it. The only way to memorize it for me has always been to write it out over and over again. A plus b squared is equal to a squared plus 2 times a times b plus b squared. Okay, so let's do this. We got x squared plus 12x, that would be 2 times x times 6, plus 36. 6 times 6. Awesome. You can do this too. So this is a different situation. We have the a minus b squared situation going on, which was almost identical. That would be a squared minus 2ab plus b squared. Okay, so what's going on? We got x squared minus 14x, right? Minus 2 times x times negative 7. I didn't say that right. It's and then plus 49. The way I was saying it was minus 2 times x times negative 7. What I meant to say was 2 times x times negative 7. So you end up with the negative 14x. Okay. All right, so that is number 17, and we are moving on to the final page. Okay. Okay, so we have one more of these trinomial and standard form things. I bet you can already tell me what it is. So remember, it's a squared minus 2ab plus b squared. So that's going to be x squared minus 2 times 9, so minus 18x plus 81. Just to be complete here, we will write down, a minus b squared equals a squared minus 2ab plus b squared. Oh, so now we're doing long polynomial division again. All right. So in that case, we're going to need to write the dividend x cubed plus 11x squared plus 28x plus 20 divided by x plus 2. Okay, and there's a few rules to remember here. A few rules of the road, all right? So let's first remember what your task is. Right now you're trying to say what times x equals x cubed? And you should just jump to x squared. So that's your first term of your quotient. So you're going to multiply that times both of these terms. X squared times x is x cubed. And then x squared times 2 is 2x squared. Okay, now these were both positive numbers, right? I'm writing it very faintly because the next step is draw a line, change both signs. Negative, negative. Right? Very important. It's probably the most missed step. This will cancel. That's how you know you did it, right? But you got to change both signs, all right? So now you got 9x squared here plus 28x. All right, so what times x will equal 9x squared? Well, it would just be 9, right? 9x. So plus 9x And we multiply that. 9x times x is 9x squared. And 9x times 2 is 18x. Right? Now draw a line, change both signs, and you should be able to cancel this term out. And now we've got 28 minus 18, which is 10x plus 20. So what times x makes 10x? About 10. So plus 10. It's going to work out to where there's no remainder, you can already tell. So you have 10x, and then 10 times 2 is 20. Notice I'm not even putting the pluses there because I know I'm going to draw a line and change both signs. And they both cancel, leaving no remainder. Okay. So I know my quotient is finished, and that's my quotient with no remainder. And remainders aren't scary in polynomial division. You just write the remainder over the divisor as a fraction. Not a big deal. All right, so now we're on to number 20. Second to last problem. And we're going to divide x cubed plus 5x squared plus 8x plus 4. We're going to divide all of that by x plus 2. Okay, so we play our little game again. What times x equals x cubed? X squared. So we end up with x cubed. And then x squared times 2 is plus, I don't want to write the plus, 2x squared. And now we draw a line, change both signs, cancel out these, and then we have 3x squared here, plus 8x. What times x will be 3x squared? Well, 3x plus 3x. Now 3x times x is 3x squared. And 3x times 2 is 6x. Draw a line, change both signs. These cancel out. You're left with 2x plus 4. Okay. So plus 2 gives me 2x plus 4. And I know that I'm going to cancel those out, leaving no remainder. Okay. And so this is the quotient with no remainder. Number 21 has a remainder. So this is super confusing to me. I think the easier way is just to remember, just put the remainder number, whatever it is, over the divisor. Okay, very simple. Just like you would do in any old division problem. Okay, so let's jump in. We got 12x cubed plus 5x squared minus 27x plus 13. Divided by 3x minus 1. Now, because there's a minus sign there, we might have to think a little bit about changing those signs, okay? So just pay attention. What times 3x equals 12x cubed? How about 4x squared? That'll give me 12x cubed. Perfect. Now be careful here. 4x squared times negative 1. So that's going to be minus 4x squared. And now it's time to draw a line and change both signs. But in this case, I'm changing this minus to a plus. Okay? I'm changing the sign, right? So here in the first instance, these cancel. And now I've got 5 plus 4, so I've got 9x squared minus 27x. So what times 3x would equal 9x squared? How about 3x plus 3x? So now I've got 9x squared. Very careful here, 3x times negative 1, that's minus 3x. Draw a line, change both signs. This will become negative, and this will become positive. Okay. That cancels. And now I have negative 27x plus 3. So 24 minus 24x. Negative 24x plus 13. You can tell when they threw this 13 on there that you were never going to get anything. So you're going to put, what? To make negative 24x, you would put negative 8. And negative 8 times 3x would give you negative 24x. Negative 8 times negative 1 is positive 8. Now we're going to change, so draw a line. Now we're going to change both signs. So this becomes positive, permitting that cancellation there. But this becomes negative, okay? So it's harder to do when you've got a plus sign. It's negative. So now it's 13 minus 8. That gives us a remainder of 5, okay? This is the remainder. Okay, so what do you do with that? Well, what you do with it is you just put 5 over 3x minus 1. So up here in the quotient area, you write plus, oh, I'm sorry, you can't see, plus, and then you put up here, try to write it real tiny, 5 over, and then down here below, write 3x minus 1. Now that wasn't that bad, right? So that's the remainder, right? It's actually exactly the same as you would do it in a normal division problem, but we don't typically have algebraic expressions in the denominator. Okay, so this is the full quotient here, including remainder. All right. So that took a little over 2 hours. So that was about 20 questions. So 120 minutes. I'm really bad at math. I don't know. How many minutes is that per question? $120 minutes divided by 21 questions. Well, let's actually do it for real. So it's actually 2 hours and 10 minutes, right? So that's 130 minutes divided by 21. We spent an average of 6.19 minutes, so about 6 minutes per question, okay? That's pretty typical for, algebra. You should expect to spend, 5 minutes, right? Maybe if I weren't narrating it, I could have gone slightly faster. But I don't know that there would be a speed that I would want you to go much faster than that. About 5 minutes a question is about right, especially for this kind of heavy stuff. So, I hope now you recognize that we have fully ejected from the safety net of early childhood mathematics, right? Now we're just fully doing like algebra, and I hope you're excited. And maybe at the same time, I don't hope for someone to be nervous, but a little excitement and a little nervousness, like, hey, this is a lot. Can I handle this? Can I really do this? Is this really possible? I assure you that you can do it, okay? That's why I make these videos, to show you that, like, to literally show you how to do it. And I go slow. Sometimes people say so slow that it puts them to sleep. But I don't know. I don't know who I would be helping by speed solving through these problems at this point in your education. So with that, we will end it there. I'm assigning this on the 11th, okay? But it's not due until the 14th. So you've got time, I'm not asking you to sit down and commit 2 hours and 10 minutes to doing all these problems in one sitting, all right? But yeah, over the next couple of days, you've got 3 or 4 days here. Can you do it in 4 days? Yes, you can, right? That's 5 problems a day, right? 5, and then 1 more, right? Because you got 21 questions. If you need help, come get me. But I don't know why you would, because I've solved every problem here, and I've explained every step. And so please utilize this video, because, it's taken me 2 hours and 13 minutes now of my time. And there's a lot of time here that's not on the recording, because I paused the recording, okay? I'm able to pause the recording and then unpause the recording, see? And then maybe sometimes you notice that I paused it and unpaused it, but sometimes you don't. But that time is not there. So maybe I spent 2 hours and 45 minutes or 3 hours on it. Who knows? By the time I get this thing formatted in Camtasia with the titles and all the numbers and all that, I'll probably have put 5 hours of work into this thing. So I really hope you use it and benefit from it. And that's a great segue into why you should subscribe to this channel. The compliment that I I am most gratified to get. I mean, I'm not sitting here loving the comments, right? I love all the comments, even the negative comments, the ones that say, you suck. I put a heart. Or the ones that say, I can do all of your algebra, but I haven't mastered, writing everything with a protractor. Like they're digging on me for writing like that. Okay, I give that a heart. That's a troll. Okay, good trolling is excellent. I mean, it wouldn't be YouTube if it weren't trolls. But it's those people that say, thank you for going so slowly and methodically through the problem, because I didn't understand it. They usually say something like, my teacher just went really fast and I didn't understand it, but you just like went through it, as if you were writing it out in crayon for a 5-year-old. Okay. Nothing to diminish you, right? I'm not talking down to you. I'm just saying that this is how I can't go any faster than this, okay? If I do, I'll make mistakes. So, I mean, this is my mathematics that you're viewing here. And it would have taken me about this long to do it, even if I wasn't recording it and narrating it. I mean, it would go faster without the narration, but still, I would have done all of it just exactly the same way. There's nothing that I did here just for you, right? This is how I would have done the math. So, and this is how you do the math in high school, and this is how you do the math in college. And I didn't dumb it down for high school. Or for 8th grade in this case, right? I just gave you the math, and you could, if you turn in this problem in a college algebra class, you would get full credit, okay? Because you're doing it the right way. And there's the rigorous way, right? So anyway, thank you so much for watching. Please make sure to like, subscribe, comment, hit the notification bell. You can join this channel, all right, and give me money, but please don't do that if you're a student. I want this to remain a free resource. I don't have any membership perks yet, so I don't know why anyone would become a member, a paying member. And I'm not on any GoFundMe or Patreon or whatever, Subscribestar or anything like that. So anyway, I hope you liked the video. I hope you watch the whole thing. I'd like to see the average view duration on this video greater than 3 minutes, which just means that people are jumping to the answers to the questions and then cutting off the video. So I do hope you watch the video all the way through, and we'll see you in the next one. Thank you.